Hello and welcome to today's class. In today's class, we are going to be dealing on differentiation. So what then is differentiation? Differentiation is one aspect of calculus that tells us how one parameter changes with respect to another. Now, in differentiation, y is expressed as a function of x. Y is expressed as a function of x. That means y is equal to f of x. Also, in differentiation, if you differentiate y with respect to x, that is dy all over dx. If you differentiate y with respect to x, it is the same thing as f prime of x. So whenever you are asked to differentiate y with respect to x, that means you should find dy all over dx. Now, let's look at the methods of differentiation. There are different methods of differentiation. Methods of differentiation. Methods of differentiation. There are different methods of differentiation. The first method of differentiation is known as the general method. We have the general method, and secondly, we have the first principle method. The first principle method. We also have the chain rule. Chain rule, or function of a function. Function of a function, or function of different functions. Number 4, we have the quotient rule. We have the quotient rule. Number 5, we have the implicit differentiation. And then number 6, we have the product rule. We have the product rule. So these are the methods of differentiation. We have the general method, we have the first principle method, we have the chain rule or function of a function. We also have the quotient rule, the implicit differentiation, and the product rule. In this class, we are going to consider the general method of differentiation. General method of differentiation. Y, assuming y is equal to f of x. Remember, earlier on I told you that y is expressed as a function of x. So y here is expressed as a function of x. And let's say f of x is also equal to x raised to power n. X raised to power n. If f of x is equal to x raised to power n, that means y is also equal to x raised to power n. Now, if we are asked to differentiate y with respect to x, if we are asked to differentiate y with respect to x, how do we solve it? So dy all over dx is equal to, now this is how general method works. You multiply x by its power and then subtract 1 from the power of x. So here we have n multiplied by x and then n minus 1. You simply multiply x by the power of x and then subtract 1 from the power of x. So therefore dy all over dx is equal to nx raised to the power n minus 1. Alright, let's solve an example or a question. Example 1. Example 1. If y is equal to 4x raised to the power 3 minus 3x raised to the power 2 plus 5x and then minus 7, and we are asked to differentiate y with respect to x. That means find dy all over dx. How do we go about it? You multiply x by its power and then subtract 1 from the power of x. So here we have 4x raised to the power 3 minus 3x raised to the power 2 plus 5x minus 7. If you multiply x by its power here, we are going to have 4 multiplied by 3, and then you attach x raised to the power, subtract 1 from the power of x, we have 3 minus 1. And then minus, for 3x raised to the power 2, if you multiply x by its power, we are going to have 3 multiplied by 2. You attach x and then subtract 1 from the power of x, so we have 2 minus 1. You close the brackets. For 5x, we are going to multiply x by its power. Now, whenever you see 5x or 3x or 2x, it simply tells you that x is raised to power 1. X is raised to power 1. So if you multiply x by its power, we are going to have 5 multiplied by 1. You attach x and then subtract 1 from the power of x. So we have 1 minus 1. So we are left with 7. So if you differentiate a constant or a number that does not have x attached to it, it simply gives you 0. So if you differentiate 7, it becomes 0. Alright, here we have 4 multiplied by 3. So 4 multiplied by 3 is equal to 12. And then you attach x. You write x raised to power 3 minus 1 is 2. So we write 2 here. And then minus 3 multiplied by 2 is 6. So we write 6 here. We attach x. 2 minus 1 is 1. So we write 1 here. 5 multiplied by 1 is same thing as 5. So we write positive 5. Positive 5. You attach x. 1 minus 1 is 0. So we have 0 here. So this 0 is eliminated already. So here we have 12x raised to power 2 minus 6x raised to power 1 is the same thing as 6x. And then plus. Now, according to the zeroth law of indices, any number or term that is raised to power 0 is equal to 1. Apart from 0, any number or term that is raised to power 0 is equal to 1. It is according to the zeroth law of indices. So x raised to power 0 is 1. X raised to power 0 is 1. Therefore, 1 multiplied by 5 is the same thing as 5. So since x is raised to power 0 and any number or base raised to power 0 is the same thing as 1, therefore 1 multiplied by 5 is equal to 5. So therefore dy all over dx is equal to 12x raised to power 2 minus 6x plus 5. So this is our final answer. Before we proceed, if you've not subscribed to this channel, kindly subscribe now. If you have a question, endeavor to leave your question in the comment section of this video. You can also like this video and share to your friends or colleagues. Alright, let's take another example. Example 2. Still on the general method of differentiation. If y is equal to 5x raised to power 4 minus 2x raised to power 6 plus 3x raised to power 2, and we are asked to differentiate y with respect to x. How do we go about it? Our first task here is to write down dy all over dx. Now remember what I said. Dy all over dx is the same thing as f prime of x. Dy all over dx is the same thing as f prime of x. So if you differentiate y with respect to x, dy all over dx becomes equal to, you multiply x by its power and then subtract 1 from the power of x. That's the principle behind general method of differentiation. So if you multiply x by 4, so we have here 5 multiplied by 4. You attach x raised to power, you subtract 1 from the power of x. So we have here 4 minus 1. You close your bracket and then minus. If you multiply x by 6, we are going to have 2 multiplied by 6. You attach x and then subtract 1 from 6. You have 6 minus 1. You close the bracket and then plus multiply x by its power. So we have 3 multiplied by 2. You attach x, subtract 1 from 2. So we have 2 minus 1. You close the bracket. So dy all over dx is equal to 5 multiplied by 4 gives us 20. So we have here 20, and then you attach x raised to power. 4 minus 1 is 3. So we have 3 here. Minus 2 multiplied 6 is 12. So we have 12 here. You attach x. 6 minus 1 is 5. So we have 5 here. 3 multiplied 2 is 6. So we write positive 6. 2 minus 1 is 1. So we have 6x raised to the power 1. So therefore, dy all over dx is equal to 20x raised to the power 3 minus 12x raised to the power 5 plus 6x. So this is our final answer. See you in our next class.